Hello, Professor Thomas.
Hello, let's see, is everything working? Yes, I think so.
Hi, good afternoon. We're so glad to have you here. It's Fumini, and I'm super excited to have you in the session today. It's been quite a while. Thank you so much for joining. We have our participants also joining now. So we might just have to wait a few minutes for them so that they all join in.
Okay.
Okay. So I think we should just give them about 2 to 3 minutes to get everyone in.
So I have in answer to Emmanuel's question, I have a long list of questions that was sent to me, but I suppose we can also have you ask questions in the chat too. So
yeah, sure. So all the questions that were filled in the form have already been sent to Professor. So you can just drop, if you have further questions or you did not drop your questions, you can just drop your questions in the chat window.
So I went through all the questions, and I've written a few slides with some overall answers. And so I thought I could begin by going through those.
Awesome.
So let me know when you want me to begin. And I mean, they're just 3 slides, and then we can go through the list of questions.
Okay, great. I think we can get started now, sir.
Okay, so let me see if I can make this work. Oops, that didn't work the way I wanted it to. No. I wanted to show up on this screen. This work? There we go. Okay. Okay, so thank you for all the questions you sent. I thought it'd be useful to have some overall discussion about how I think about the current situation in data science and machine learning, both in industry and in the academic world. So let's see, missing mouse focus here. several of the questions that you asked were about what kind of background and preparation is needed. And I think it depends a bit on what the roles are that you want to have. You should remember to mute your microphone when you're not. There we go. Good. So I think there are a lot of different roles, and maybe I've missed them here. But one role is as a data analyst, and often as a data analyst in industry, you're given a series of analytical questions from management. So a lot of it is ad hoc data analysis to answer specific questions. Say your company is considering going into a new line of business, or acquiring another company, or accepting an offer to be acquired, or things like this. Then you're going to be given the task of trying to understand the costs and benefits of that based on whatever data you have at hand. Another role is as a machine learning engineer. And here the focus is more on automating business functions. So building machine learning systems that automate business functions. And those could be customer-facing functions, like giving recommendations to customers, presenting them with advertisements, an intelligent user interface. I mean, if we think about the machine learning is now embedded into the email and Google Docs composition windows, where it does predictive typing and things like this. And also customer retention actions, say deciding to offer a customer a coupon or a cheaper price, things like this. There's also business to business kinds of business functions, right? Demand forecasting, supply chain management, these are huge things. And then there's inside the business operations, things like predictive maintenance, if you're operating a fleet of vehicles, or a chemical reactor, or just a building with heating and ventilation. You might also be optimizing those operations to reduce their costs. Or you might be concerned with fraud detection, cybersecurity, things like this. And then, of course, there are businesses whose core technology is created using machine learning. So I think these days of things like medical imaging for ophthalmology, or medical diagnosis, or insurance underwriting, things like this, in which case the machine learning engineer is working on absolutely the core of the company. A third role seems to be ML ops, and I think this is a real growth area, because you know, a colleague of mine who used to work at GE Corporate Research, Piero Bonassone, he was doing machine learning applications in the 90s, in 1990s. But he said he couldn't afford to do very many applications because he had to send one PhD with each application to keep it running. And that is the real mark of immature technology, when you need a PhD just to get a piece of software to run. But things are changing now, right? So now we have some ML ops tools, and we see that machine learning systems do require continuous development and periodic, say daily, weekly, monthly retraining to update them. And of course, that relies also on managing the quality of the data that's coming into your system, detecting changes, removing anomalies, all of these kinds of things. And then, of course, there's machine learning R&D, which is more, of course, what I've spent my career doing, which is benchmarking existing methods, developing new methods, analyzing their relative strengths and weaknesses, and for instance, figuring out how to optimize application-specific metrics, because we often see in a real application that things like accuracy or area under the ROC curve, these are not the metrics that really matter. The key performance indicators are going to be much more related to the line of business of the organization. So those are some of the possible roles. Now, what kind of training or knowledge do you need for them? Well, if you're a data analyst or a machine learning engineer, it's important to have broad knowledge of many fields, because you'll often be, especially as a data analyst or data scientist, interacting with a wide variety of subject matter experts on all kinds of different problems. For instance, if you're working on predictive maintenance, then it helps to have had an introductory course in physics or in mechanical engineering, so you understand the vocabulary people are using, for example. Or maybe you're working on managing a chemical or biological production line, in which case having had some background in chemistry and biology is useful. Or maybe you're working on customer behavior or intelligent user interfaces or issues of fairness and ethics in deployed machine learning. Then you need some background in social science. So you can see for each of these, you're often bridging between the technical capabilities of statistics and machine learning on the one hand, and the problems that the company faces. So you kind of have a career choice to make, I think. You can either stay within one area, say physics and mechanical engineering, and become a very deep expert in that area, and you know, be the god of predictive maintenance, for example. Or you can be a generalist, and I think for data analysts, it's often useful to be a person who is curious and eager to learn new things, learn new terminology, learn new challenges. And over the course of your career, you might work in a dozen different areas of knowledge. And you'd working with a subject matter expert in each case to understand the problem and then to formulate a solution and then solve it. You always, in this role as a data analyst or machine learning engineer, need to be familiar with different problem formulations. Not every problem is a classification problem or a regression problem. And so I think you need to understand about time series analysis, spatial statistics, survival analysis, multi-level or hierarchical regression models, functional data analysis, where you're mapping from an input function to an output function, cluster analysis, all these different paradigms that have been developed in statistics and then more recently in machine learning, because given a new problem, you're going to have to figure out how to formulate it. And of course, there are other things that really have been done outside of statistics, like recommender systems, matrix factorization problems, topic modeling, you know, language models, object models, scene models, all these different things. If you're going to be, on the other hand, moving away from a focus on the data analysis itself and more into the engineering and operations, it becomes a lot more important to have strong background in software engineering, operating systems, distributed computing, distributed databases, privacy and security, and to understand all the machine learning frameworks and libraries, know about containerization and virtual machines and parallel computing, all of these things. And if you're going to be doing machine learning R&D, well, you need a lot of mathematics. So obviously you need to have mastered your algorithms and data structures, but you need to understand the mathematics of linear algebra, of vector calculus. Now differential equations is becoming important as people start to fuse deep neural networks with physical models, ordinary differential equations. And optimization, of course, is the central mathematical problem to solve when fitting a model to data, is you're modifying the model parameters in order to optimize, say, the log likelihood or some other metric. And so you need a background in machine learning theory and statistical theory. So that's quite a range, and you know, no one person can do all of these different, have all of these different areas of expertise. And let's see, I think some of the questions were about, well, how do you get experience? And I think that obviously a fun place to start is by downloading data from a Kaggle competition or downloading code from a published paper and replicating what's been done, or even competing on Kaggle. And you can learn a tremendous amount doing that. However, I don't think it's sufficient. You need to work on a problem from initial formulation through deployment. So certainly when I'm looking for a promising student, I'm interested in whether they, you know, I ask them, where does the data come from? And if the answer is, well, it comes from this website, then that's a fail. The question is, how was the data collected? And maybe what kinds of sampling biases does it have? What are the issues with that data? What kind of noise does it contain? And then how are we going to formulate the problem we're trying to solve? Is it a problem of prediction, of clustering, of recommendation, of anomaly detection, novelty detection? If we fit a model to it, what might undermine that model over time? What are the threats to model validity over time? Will users, once we deploy the model, will user behavior change in a way that will invalidate the model? I mean, the clearest case of this is models that try to predict the stock market or take advantage of arbitrage opportunities on the market. As soon as you have a tool that can do that, the market will change to make your tool fail, right? And so then how are you collecting the data for your problem? How are you cleaning it and designing good features for it? And then how are you constructing your model and validating it and debugging it? And then when you deploy it, how are you monitoring and dealing with the need to retrain from time to time? So these are the kinds of issues that you get experience with if you work on a problem all the way from its initial formulation through deployment. And if you can get experience on that, even on a problem of your own, that's fantastic. So I think it's best to do this as part of a team. I would start in a knowledge domain that you know very well, so that you're not spending a lot of time learning subject knowledge. But then for your second system, I would say, you know, trying to get an internship or starting your own small company might be a way to build this kind of experience. And of course, universities exist for a reason, which is to give you opportunities to learn this stuff. But in addition, they give you the mathematical and statistical and computer science background that you need. So another thing to consider when you're at university is to take introductory classes in many other fields. So taking the introductory class in physics, in chemistry, in biology, then you know at least some of the terminology about, you know, what is an aromatic ring or what is a base pair in DNA, things like this. But I would say if you want to go on and do machine learning R&D, mathematics is the single most important thing. I think having a background in physics or maths may be more important than a background in computer science in terms of, or statistics in terms of your ultimate success in machine learning R&D. I mean, obviously you need to have programming skill and understand algorithms, but it's the mathematics that I find is the limit that most people encounter as they go forward. So I think that's all I have for slides. I'll stop sharing and we can start talking about the questions that were sent to me. Let's see, click escape to exit. Okay. And did that stop the sharing? Yes, I guess so. Okay, so yeah, I'm certainly happy to share those 3 slides. Yeah. Okay, so let's see, what were some of the questions that I was asked? The first question was, do you need a master's degree to advance in the field of data science? Well, as I was trying to say in the slides, I think the answer is you either need a lot of experience working on real problems or a master's degree. But there are many people who have been very successful without a master's degree. But you need to build that kind of experience about all phases of the development life cycle. Let's see, the second question was, how do I become one of the greatest data analysts in the world? Well, I think obviously you need to know your tools really well. And so being an expert at the at pandas and Python or R or Stan if you're like to do Bayesian modeling is critical. But then, as I say, you need to have experience in understanding the vocabulary of the application areas in which you're going to be working. And so you have, again, that choice. Do I go deep in one area, or do I become a generalist who knows a lot about many different topics? So you can carry on a conversation with someone about the risk of grasshopper infestations in pastures, or about the design of drug molecules, or about maintenance of heating and ventilation systems, right? I like to say that a data analyst is a professional dilettante because you know a little bit about many, many topics, enough to communicate with subject matter experts in all those fields. A third question was, I'm a self-taught computer programmer but with a master's degree in engineering. I've gone far in ML and data science and deep learning, and I want to transition my career to become an ML engineer. Am I qualified to apply for a PhD program? So I guess the first thing is the words ML engineer and PhD program don't necessarily go together. I think a PhD is a research degree, right? And you would be going into a research and development career with a PhD, in which case being self-taught in computer programming is not the same as understanding computer science or statistics as a research discipline, right? How are new methods developed? What are the fundamental principles that underlie existing methods, right? Understanding probability theory and measure theory and probabilistic inference, all of these kinds of things. So I don't think that I think you need to get research skills if you want to be a PhD and have a research career, but I'm not sure that that is what you want. Right. Let's see, the next question was, what are the key things that inspiring data scientists must not be neglected while building a career? Well, I mean, I've already touched on a lot of them, I guess, but I think when you're developing your career, you might be specifically seeking out opportunities where you get a chance to acquire a new skill. So, you might work in a new area in order to learn some of the subject matter expertise for working in that area. So if you want to build breadth across many different intellectual areas. Let's see. I think I've addressed some of these. I got a question, how can I stop procrastinating and start learning data science with my 9-to-5 job? Well, that is tough. I guess my only thought was, is there some aspect of your 9-to-5 job that could be a data science opportunity? Or, if you think about how the place where you're currently working, could it benefit from data science and data mining, machine learning in some way? But maybe, I guess the advantage of thinking about things that way is you already understand the organization you're living in, that you're working in. And so maybe that's where you can see opportunities to make things better. And you may not be able to actually make them happen, but it's a good way of trying to integrate the two. Is there any scholarship opportunity for data scientists in your university? So at Oregon State University, we provide financial support for all of our PhD students and some of our master's students. But there are relatively few scholarships available for undergraduates or master's students in general. So again, if you're interested in a research career, there's lots of money available. How would you advise someone to start working his way to the top in data science? Well, the famous computer scientist Donald Knuth used to say that to get a PhD, you just have to solve a series of harder and harder problems. He said, first you solve a problem that only takes you a minute to solve, and then one that takes an hour, and then one that takes a day, and then one that takes a month. And when you get up to solving one that takes you a whole year, then you get your PhD. So I guess that would be my advice in general, is to try to construct your career as a series of challenges, starting with things that are easy, or at least that look easy, because almost everything that initially looks easy turns out to be difficult, right? I like to say that, you know, in data science these days, it's sort of like going out into the forest and you pick up a rock, and under the rock there are all these bugs living there. And it's just like even a simple rock looks like it has a lot of complexity behind it. Let's see. What is the best way to gain more hands-on experience? Well, I think a place to start, right, is to do the kinds of things that you had to do for Data Science Nigeria, which is to solve some problems or challenge problems, say, competing in some Kaggle competitions. But going beyond that, I think you have to get an internship, or maybe think about starting your own business based on some practical problem, and see if you can, that will give you the experience. Even if the business totally fails, it'll give you the experience with the entire process. What are the career prospects and options for a person with an electronics engineering background in data science, and how can machine learning be used in the electronics industry? Well, I think there are many opportunities for machine learning in the electronics industry. I actually have a paper looking at integrated circuit manufacturing, because like any manufacturing process, there are all these stages and there are opportunities to improve things. We were looking specifically at the problem of what's called wafer scale test. So, you know, when you are manufacturing integrated circuit chip, they're usually manufactured on these very large silicon wafers, right? And there are many, many copies of the chip, which are called the individual dies on that wafer. And when a wafer is manufactured, it is tested while it is still a wafer before it is chopped up into the little chips, and the chips are then mounted in packages. And the question was whether we could detect manufacturing problems by testing at that wafer time. And we built some probabilistic models for that purpose. So that's just one example of the kinds of things where you can, in our case, the probabilistic models were not classifiers, but were just probability density models. So we look for unusual patterns of failures on a wafer. Nowadays, also, there's a lot of excitement about the Internet of Things and edge computing, right? The idea that we're going to have smart devices, smart sensors, and they're going to have some computing on them, maybe even small neural computers that can do some, at least, maybe not training, but running deep nets, but maybe even training networks and deep nets and other machine learning things, and communicating with each other over the internet. So if you are in a situation in the electronics industry where you're developing novel sensors and wanting to put computing in them, then there will be big opportunities there for detecting sensor failure, detecting, keeping security and privacy, and distributed, like federated learning. So let me look at the chat for a moment. Let's see.
Okay, yeah, so we've gotten some questions in the chat.
Right, okay, yeah. So let's say, is it a must to be proficient with databases in order to work in the field of data science or as an analyst? I don't know if it's absolutely essential, but it sure is useful. I mean, most data lives in databases, or you're going to need to store it in databases. So you definitely need some skill in that. Of course, there's been a lot of move to different kinds of databases. So, NoSQL databases and things like this. So it's a never-ending, it's a moving target always. let's see. A couple people mentioned that DeepMind has some scholarships. Right, I mean, I only answered the scholarship question from the point of view of my own university. But I do know there are other opportunities out there, and that would definitely be one to check. Let's see, how can machine learning be fused with mechanical engineering? And how exactly can you input your model into a machine? So, I guess they're all kind. I mean, mechanical engineering, of course, is so broad; it could be almost anything, including all of robotics. I guess I'm most familiar with applications in mechanical engineering that involve smart buildings. So, putting a bunch of sensors on the heating and ventilation systems of a building, on the doors, on the windows. But of course, there's also interest in using machine learning to try to improve mechanical design, which we can usually think of as an optimization problem. And this is an area that I actually worked in back in the 1980s. But I'm not sure I have a lot of intelligent things to say about it right now. There's a lot of interest in using GANs, generative adversarial networks, to synthesize novel shapes for products. So you can train them on a bunch of parts, say, and then maybe use them to design new parts. Similarly, they're being used, graph neural networks are being used for designing chemical molecules, drug molecules, things like this. So there's all kinds of things happening in that space. Let's see. Can machine learning applications be offered as software as a service? Well, of course, BigML is a software as a service company. We originally thought that there would be a secondary market in trained models, and that people could use could sell model predictions as a service. But that's turned out to be quite challenging because of these model inversion attacks. People have shown that you can, if you have the ability to ask arbitrary questions of a predictive model cheaply, then you can basically reverse engineer the model, uncover the underlying data, which could break privacy or would let you train a model of your own, and then you don't need to pay for the model predictions. So privacy-preserving machine learning has become a field as a result of that experience with BigML. Let's see. Okay. There are many questions here. So is online certification worth it? I don't know the answer to that question. You know, when I see, for students that are applying to go to graduate school, I see applications. Some of them have some online certifications. That's not very helpful for me because I don't really know what's involved in that certification. But if they have work experience where they've worked on something and produced some product, then that's much more important to me. Or, you know, if they've already done some research. But if they've done a lot of research, then why are they now proposing to go to graduate school? There's a chicken and egg problem there. As a graduate of mathematics and statistics, can I proceed with an MS in computer vision? Is that the question from Mohammed? I would say yes. I mean, you're going to, you know, as a master's student, you will take the classes that you need in computer vision. So I would say yes. Is it compulsory to have a Bachelor's of Science in Data Science or Machine Learning before pursuing a master's degree? Well, you need a bachelor's degree of some kind before pursuing a master's, but I wouldn't say that it has to be in data science or machine learning. It could be in computer science, it could be in statistics, it could be in physics, it could be in electrical engineering, right? I mean, any subfield that gives you a strong mathematical background, and then coupled with some experience, even just self-training, self-teaching experience, I think is really all you need to then be very successful in a master's program. Let's see. How does math and calculus apply to data science beyond understanding the algorithms? Well, of course, its central role really is the design and analysis of algorithms. But when you're, we're seeing now more and more the integration of physical models or simulation models with machine learning. So there's some very exciting work on showing how, the same tools that let you, if you're familiar with AutoDiff in say, PyTorch or something, right? You describe only the forward pass through your deep network, and then it automatically calculates the derivatives for the backward pass. If you want to extend that to include new structures, then you need to understand your calculus to do that, right? And if you, but people are also doing things like putting a differential equation solver inside the deep net, so that the deep network can essentially integrate differential equations as part of its functioning, or including an optimization step inside the deep net and then having differentiation through that. So I think that's the big advantage of this, right, is that you can have a network that already knows the laws of physics, so it doesn't have to discover them from data. And this can make for very rapid adaptation. It can also give you safety guarantees if you're building a neural network controller for an aircraft or a train, a locomotive, or a car, knowing that model is based on sound physics and not just some model fit to a set of data, gives you much more confidence that it'll work correctly. So I think that's why you need that deeper background in mathematics. Let's see. As I was saying, I think, let's see, with the diversity of the data science field, how does one identify an area of specialization? Well, I mean, my own sense is maybe opportunistically, if you get an opportunity to work in, I don't know, finance, for example, maybe you say, okay, I'll specialize in finance. Or if you are involved in, say, a company in logistics or transport, maybe you say, okay, well, I'm going to specialize in smart logistics. I don't know, I've tended to be quite opportunistic in my career, so maybe that's why I'm answering that way. I think it's pretty hard to plan a career, far into the future. One of my mentors, Ed Feigenbaum, used to say that it takes about 10 years to have a serious impact to do a big something that really will make a difference. But in your career, you maybe have 4 opportunities to do that, 4 10-year periods in an ordinary working career. So don't try to plan numbers 2, 3, and 4 before you do the first one. Let's see. Any practical advice for starting an analytics business when using data science for decision making? How do we go about data gathering and collection? Of course, in data science, we're totally dependent on having data. So the standard strategy for if you can't acquire the data from some source is to try to figure out how you can create an initial service or application that then lets you collect data. So we've seen, for instance, if you were wanting to build a automated help system for customers, first you build a telephone-based support system for customers, and you collect the questions and the answers from that, and then use that to try to build an automated version of it. So that's a typical strategy. I have a background in education administration. Many people feel sciences have an upper hand in data science. what would be your suggestions for me, especially regarding applying for opportunities? I'm curious, actually. I mean, this may be too much of a blue sky answer, but a central problem in the administration of a large organization is to ensure that all the different groups within that organization are all working in the same direction, trying to achieve the same goals. And management often doesn't know whether that's true or not. And I think it may be that an important role for machine learning and for artificial intelligence more generally is to provide much better, let's call it situational awareness, by having an understanding of what all the different groups are doing and monitoring that in some way. And you have to think very carefully about what monitoring would be appropriate. But you could be monitoring sales, you could be monitoring repair orders, whatever. You could help give higher management better visibility into all those various components. So maybe something like that, where you think about how do I support the upper management with a sort of custom built machine learning system might be a way to try to sell yourself if you have more of a managerial background. People who have worked with numbers for their whole careers can't really do that kind of people skills job, which is more at the managerial level. In what practical ways can I start creating a business value with my knowledge of machine learning? Well, I mean, if I had a good idea on that, I would do it myself. I think this is where you really have to think creatively and talk to lots of people. And look for that opportunity where I like to say, if you think about how an organization or a customer is making their decisions today, and what are the steps where they feel like they're just making a guess because they don't have enough information to make the right decision. That's a place that you can target some decision support, some machine learning recommendation system or something like this, right? So, so that's one thing, is look for those places. I mean, I usually apply it even as a machine learning researcher. I say, well, what steps in the typical data science pipeline do we feel like we're making arbitrary decisions without any guidance? Those are the ones where there's a research question to answer, which is what would be the way that you could automate that decision? How can someone without a degree and no experience break into the data science and machine learning field? Well, you need to get a degree or get some experience, right? So I would say you could start by getting some experience with learning Python, learning pandas, or learning R, and trying out some Kaggle competitions or something like that. Let's see. What course at the master's level would be more beneficial to study as a graduate of agricultural economics who has an interest in data science? Yeah, agriculture, I think, is an area that has tremendous opportunities going forward for data science. A lot of that is going to be enabled by having better sensing, whether it's using cameras or soil moisture sensors, or I mean, people are looking at robots that might inspect fields. I'm not sure that sounds like it could be an expensive toy, but being able to go out and, for instance, take images of crops, maybe taking also overhead images from drones, and then looking for patterns in that data and relating those to diseases, to fertilizer needs, things like this, water. Seems like the basic thing. And then there's the whole estimating the demand, product demand, understanding prices, forecasting them. Let's see. I'm getting so many questions here.
Okay.
I want to remind you to mute your line if you're not if you're not during this meeting, I guess. Let's see. how can I integrate AI into power systems engineering? I've seen a few lines in that direction. I mean, one is more about, for instance, if you have a large solar array and you're doing solar power, how do you identify panels that are malfunctioning and need servicing, need cleaning, need replacement? So I've seen work on that, where maybe you need to do detailed modeling of how shadows from trees or other buildings causing some panels to not produce power at certain times of the day. And so you need to understand that those are not failed panels. That's just part of their normal behavior. So treating that as a kind of a prediction and anomaly detection problem. There's also some work on managing managing batteries. So managing energy storage. So we can see that when do you switch to battery power? When do you switch to solar power? What's the optimal way to be charging up your batteries to make extend their lifetime, capture the most energy in the most efficient way? These are all problems where having predictive models can make a huge difference. I also have colleagues that work on trying to prevent blackouts by having sensors that are sensing the electrical power grid at various points, and then trying to make decisions in just a few milliseconds about whether to partition the grid into independent parts to prevent a blackout from spreading from one part to another. So I think there's a whole range. And then we could get into billing and consumption and giving advice to end users, customers, about how they might be able to reduce their costs. I'm now getting an email from my electric power company, since they put a smart meter on my house, telling me, oh, I'm using more electricity for heating than I have in the past, this kind of thing. Okay, can I say some words about ML in healthcare? Well, I don't have much experience in machine learning in healthcare, but it is a big area. And there's a sense that there's all of this medical records data that is accumulating now as healthcare itself is starting to be transformed digitally into electronic health records. But there seem to be huge challenges in moving in applying machine learning and AI to understanding electronic health records. It may be that the interesting opportunities have to do with individual sensing modalities. So, we see that now. I believe Dr. Odaibo is presenting on ophthalmology and looking at eye diseases, analyzing X-rays, analyzing MRI images. So a lot of the kind of intelligent image processing can be used to do diagnosis and treatment. And so deep learning seems to have many opportunities to improve there and to build better tools for radiologists. But other people are more ambitious about doing things like detecting adverse effects of drugs and drug interactions when people are taking multiple medicines, and detecting prescription errors when the professor or the doctor prescribes the wrong drug for a purpose. So these are more monitoring for dangerous effects. There seems to be opportunities in wearable computing. So I'm not into this, but a lot of people are wearing heart monitors and blood pressure monitors and all kinds of things, and then analyzing that data to look for trends that might signal the onset of a disease or something like this, or help with
Oh, wow. Sorry about that, sir. Just a minute. Okay.
Okay, things are back again. Okay.
Yeah.
Well, let's see. I have my master's in environmental chemistry and pollution. Can I figure out problems to use machine learning for? Well, there. One thing again is a lot of work in monitoring. So because sensors are getting cheaper, you can imagine having, say, water sensors that are monitoring for contaminants in water. I had a project using biomonitoring. So we know that that a healthy freshwater stream has certain insects that live in it, and so we were using computer vision to identify those insects and count them. But there's a lot of work on, say, air quality monitoring, and then trying to use that to detect patterns and possibly to then figure out the sources of pollution and so on.
Sir, you skipped my question.
Yeah, they're scrolling by. Let's see, what was yours?
How can I transfer my model from notebook to say a MEMS device, and the one before it also?
Yeah. Okay, so I don't know the answer about how you can transform a network to a MEMS device, because I don't know anything about MEMS devices. So I can't answer that. Let's see, what was your other question? Let's see. So there was a question from Timidayo Omoni that said he's passionate about computer vision, has a degree in electrical engineering, and his professor recommended that he find a way to integrate machine learning with automation engineering. What course can I study in my master's that would cover both aspects? Well, so I'm not exactly sure about what automation engineering you have in mind here. There's certainly the area of visual inspection of manufactured items to see if they were correctly manufactured, to detect manufacturing errors. And that's been a topic in computer vision for a long time. Deep learning is now having a big impact there. So you could certainly take classes in computer vision and deep learning, and then look at applying them. Obviously a big issue there is how do you learn what the correctly manufactured product looks like, and how do you learn what the different kinds of manufacturing flaws look like. I've also, there's a company here in Corvallis that works on real-time management of sawmills for taking timber and sawing it up, and they do real-time identification of the log as it's going through the mill and making decisions in just a few milliseconds to decide how to process it. So if you're in a situation where you're dealing with raw materials, then let's see. Yeah, for a link to my wafer paper, yeah, all of my publications are available on my webpage under the publication section. So I think it was about wafer scale test. Let's see. Okay, so yeah, my Twitter handle is, let's see if I can get this right. I am at @tdietrich, and you should be able to find me on LinkedIn. Just search for me. Let's see. What course at the master's level would you recommend for a biology graduate? Wow, there are a lot of options there. So I guess the question is, do you want to stay in biology, basically be a biological expert who applies machine learning, or do you want to switch to being mostly a machine learning data scientist type person? If you want to stay in biology, you could think about I mean, I have colleagues who work in plant pathology, so diagnosing plant diseases, and then using computer vision machine learning tools for that purpose. So that's the first thing that occurs to me, I guess. What else should I be thinking about in biology? I mean, of course, there's also all the work in genomics and sequence analysis, and this is also largely based on machine learning tools. There's also now work on drug design and drug activity optimization. That's at the interface between biology and chemistry. So there are biologists, molecular biologists studying, say, cell membranes and membrane-bound receptors, and then using machine learning tools to design drug molecules to bind to them. So those are some possibilities that just occur to me. I worked in a startup pharmaceutical company back in the early 1990s, and we were working on drug lead optimization. So once you had an initial idea for a drug molecule, how could you make it more active? Okay, questions about mining, mineral resource allocation. I'm sure there are opportunities there. I've had one of my students went into the oil industry and was looking at reservoir modeling. So as some of you may know, when you dig perforate and make an oil well, you then can send an instrument package down that well and measure all kinds of properties along the well. And if you combine that information across multiple wells and also with seismic information from setting off explosives and listening, you can try to understand the layout of the oil field and where you should be placing new wells, and many other kinds of decisions. So actually, some of the earliest work in statistics, which was done in South Africa, is about spatial interpolation, having dug holes, exploratory mines in various places, and then trying to model the shape of an ore body. It was the original goal of kriging, which is a Gaussian process spatial modeling technique that is being discussed in a parallel session, I think, right now. Let's see. What have I missed? Mining. What is the ultimate area for an AI researcher to explore, where if he or she makes a major breakthrough, it could earn the Turing Award? I wouldn't do deep learning because that's already earned a Turing Award. I think the most difficult challenges in artificial intelligence right now have to do with meaning, right? We have natural language understanding systems or natural language processing systems that can do shallow natural language tasks. They can predict the next few words in a sentence. They can translate from one language to another, well enough to be usable. But to have a system that can do ongoing natural language dialogue, it needs to be modeling what the other person in the dialogue is thinking, what questions they have, what they understand, and what they think you are thinking about them. And representing all of that is something that is a big open challenge. So I would say that language and reasoning and all of the things associated with it, that's probably the biggest challenge that artificial intelligence faces these days. But I also have to say that I think trying to design your career to win the Turing Award is probably not the most the best way. I think the best way to think about things is if you are going to devote 10 years of your life to trying to do something, what's a sort of 10-year size project? And it will be as sub-problems of that you might uncover the things that might lead to big breakthroughs. So I think it's good to you need to have very deep and detailed knowledge in an area to make a highly significant research contribution. There's no substitute for just a huge amount of time spent in an area. Can you recommend a website where I can find research papers in artificial intelligence? Well, the main place to go is archive.org, right? This is where people post preprints of virtually all the papers that are coming out in artificial intelligence around the world, show up on archive before they show up anywhere else. Let's see. What course can I study in PhD as a master's level industrial engineer that fuses perfectly mechanical engineering with artificial intelligence? Well, my first thought there is robotics, because that is the fusion of artificial intelligence and mechanical engineering. How can one easily understand ML papers as a beginner? Well, you can't easily understand ML papers as a beginner. I can't understand a lot of ML papers, and I've been doing this for 40 years. You have to be patient with yourself, and you know, read a paper many times. First, trying to understand what is the question, what is the problem the paper is addressing, and then trying to understand the methods. And often you're going to need to look at the papers they cite and go backwards in time and find the early papers on the topic. Those are usually easier to understand than the later ones, because the later papers assume you've read those earlier ones, and so they don't give you the background that you need. Obviously, you need to read some textbooks to get the intellectual frameworks that are necessary to understand the papers. So reading papers, while it's absolutely critical to doing research, isn't where I would start. I would start with mixing hands-on experience and textbook-based study. Now we have a lot of textbook material, online courses, and so on available. Let's see. Is there a pipeline to follow for beginners? Okay, that was what I was trying to say. Can machine learning algorithms be used for foreign exchange trades? Well, there are people that try to do that. But I think when you think about trading, you know, you can try to be, you know, there's sort of the fundamentals people, and then there's the statistical type people. And both of them claim that theirs is the one true way to being successful in any market trading system. I think markets tend to, once someone has found a way to exploit some information, they tend to wipe out that information. So, and that would be true for foreign exchange as well as anything else. It's a very risky job to be in. But you know, I went for a tenured professor job instead, so I'm obviously risk averse. Let's see, a bunch of stuff scrolled by here. How can one adjust in an environment with a fast-growing technology advancement, such as a learner and as a professional? I don't know. I mean, I'm constantly trying to keep up with the literature in an area. Fortunately, more and more people are starting to write review articles and tutorials to help you understand what's been happening in a particular research area. And so that seems to be, reading those review articles is a great place to get an update on the sort of what's currently happening in an area. I was just part of a big team. We wrote a review article that is available on archive on anomaly detection. And it was led by a group at Technical University of Berlin. And so that would be a place, for instance, to get an overview of anomaly detection and how people are currently thinking about it. Let's see. How can I fuse chemical engineering with AI, and how can we use it to create new reactions and also reaction optimization? Well, this is not an area that I know a lot about. I just, you know, I serve as one of the moderators for archive. And so I see papers going by in archive that are using these things called graph neural networks, and because you can, using a graph, you can describe molecules as graphs. You can also describe synthesis pathways as graphs. And so they're able to, for instance, fit models that can try to predict the various molecular properties from their graphs. And then also techniques for trying to optimize those properties by optimizing against the learned model. Now, in general, optimizing against a learned model is a very risky thing. That's what reinforcement learning does. And typically, the optimizer just finds the places where the model is broken. The model is too optimistic, and it gets very excited about those points. So, but as part of a larger experimental framework, that's an area that seems to be very active. Let's see. While you took up a career in data science, what was your learning routine? What kept you going? What principles do you hold on to? You know, as I said, I don't know that I've had principles, but I have followed just interesting opportunities that came up. My fundamental interest in machine learning really came from studying philosophy of science during my undergraduate years. I majored in mathematics, but I took a class in philosophy of science and philosophy of government, actually. One of the central questions philosophers ask is, how is it that we're able to learn general knowledge about the world from the specific experience that we have? And how do we go through a series of rational steps from the common sense world we understand to, say, quantum physics, which is completely not intuitive at all? And I'm interested in, of course, in how computers can similarly learn from experience and learn general, say, causal knowledge from interaction with the world. So that's been the central question in my career, I would say. But I've also gotten very interested in just the technology, because I love the craftsmanship of computer programming and software engineering, and the mathematics behind it as well. So, you know, I just love ideas, and I like to say, if you love ideas more than you love money, then you should become a professor. And so that's what I did. Let's see. I'm a biochemistry student and want to dive into genomic data science in my master's study. Can I give you advice? I mean, I think it's an important area. I've been peripherally involved in some projects in this area, but do I have any specific advice? I don't know. I mean, people are looking at, you know, have been using recurrent neural networks for modeling genomic sequences, but we've seen that the transformer type model is very powerful for language processing. So now people are trying to use the transformer type of neural network architecture. So if you don't know what that is, well, you can Google it and find out. But these are different deep neural network architectures. But I think the long-term trend is to try to get away from a purely statistical way about thinking about biological molecules and think about how can I bring in the biology and the chemistry into the process as well. For instance, when I was early in my career, I got interested in this problem of protein secondary structure prediction. Given the sequence of amino acid residues of the protein, how can we predict how the protein will fold up into 3 dimensions? The early attempts were purely statistical, and they made a certain amount of progress, but they really ran into a brick wall at like 75% accurate or something like this. And it was really only by bringing in molecular kinematics and energy field models that people were then able to do better. So bringing in more of the chemistry, bringing in more of the biology, I think is the way to make progress. You can't do it with just statistics. Let's see. If you were to start learning all over again, how would you go about it? What a great question. I would take more math. I'm constantly feel limited by my mathematical limits. So I would also just try to become better at algebraic manipulation, because I still make so many mistakes. I always have to check my work in Mathematica. But I would study more mathematics. I think particularly functional analysis, more real analysis. I'd study more signal processing. I think machine learning people in computer science are not exposed enough to ideas from signal processing, but it's a very closely related field. I did have the benefit of studying information theory, and I recommend that to everyone. So let's see. How do we couple machine learning model with mobile apps and web apps? Well, of course, that's what everybody is doing these days. So in some sense, you just do it. But more to the point, I mean, we're seeing that our mobile platforms are going to be getting neurocomputing chips of various kinds on them, right? So we should be able to do fast neural network computations on handheld devices and laptops and so on, and maybe even in IoT devices within 5 years. I mean, we see that the latest iPhones already have a neurochip on them for the speech and image processing, and Apple has just announced, you know, that they're now making their own silicon now, and so they'll be building in some of those things maybe in their system on a chip setup. So, of course, this means that we need to think about, and there's a very active area of knowledge distillation. So we often find that we have to use an overly large neural network during the training process, but then it can be pruned and distilled and quantized down to a much smaller and much more energy efficient structure for deployment. And so there's a lot of research there, and doing that well, I think is an area, it's a growth area. Let's see. Is a master's in nanotech a good fusion with AI? I don't know. I think that nanotech, and to some extent advanced mechanical engineering in general, the interesting question is how much of the so-called computing can be done by the materials themselves rather than by digital computation, right? So I have colleagues here at Oregon State, right? We have a very strong program in robotics. And there's this guy, Hurst, who has a bipedal robot called Cassie. And he's got a startup company, and he sells it. He has a version now that has arms for a package delivery robot. But part of the key is that a lot of is that very little actuation is needed for it to walk. The materials store energy, just like the tendons of a human leg store energy during the walking cycle. And so I think the co-design of, say, reinforcement learning AI controllers with the materials and the mechanical systems, designing them together to be extremely energy efficient, and is the frontier in terms of advanced systems that will be cheap and reliable. Let's see. Yes, it is true that professors in the U.S. are well paid, at least in engineering. Does a postgraduate degree in discrete mathematics or combinatorics have a great impact in machine learning and deep learning? I think I would have said yes 20 years ago, because most of the optimization algorithms we were using were combinatorial optimization techniques. But since then, we've seen that using continuous relaxations, so things like linear program relaxations or semi-definite programming relaxations of discrete problems, is giving us a lot of power. And those are differentiable, and so we can put those into deep networks and differentiable programming more generally. So the ability to walk back and forth between continuous and discrete mathematics is very important. Conversely, we see that often planning problems, say in logistics or something, or even robot planning, can often be solved better as discrete search problems than as continuous ones. And so we see things like Markov chain Monte Carlo techniques, Monte Carlo tree search, stuff like that, randomized tree searches. So, so we're seeing a lot of interplay between continuous and discrete mathematics. What is the right starting point for mathematics? I say linear algebra is the #1 thing you need to know, because that's gives you a bunch of important tools, both in statistics and in deep learning. Let's see. A question has come up about cybersecurity. I mean, cybersecurity, of course, it's a kind of thing where you need to combine every technique you can possibly combine. We've worked a bit on using anomaly detection for cybersecurity. And so I'll be giving a talk with some results from that. I think that's tomorrow. So if you want to know more about that, then that might be helpful. Do I have a mentorship program for the budding AI enthusiast? Well, I have been involved in some mentoring. There is if you're interested in problems in sustainable development, I'm part of a network called CompSustNet, which is about computational, what we call the field of computational sustainability. And so this could be, you know, species conservation and wildlife management types of problems. Anti-poaching in Africa has been a big application area, but also things like sustainable development, transportation systems, public services, water systems, poverty reduction, healthcare, all of these fall within that umbrella. We have an annual doctoral consortium, I think it's called, where we do a lot of mentoring. If you attend conferences like the NeurIPS conference or the ICML conference, they have sessions for first-time attendees, and we do a lot of mentoring there. So I've been a mentor in those programs. There are also there's Black in AI, an organization that is interested in promoting AI in Africa and also in the African diaspora worldwide. And they run workshops associated with some of these meetings like NeurIPS and ICML and iClear, and they do a lot of mentoring. So, and of course, here I am doing some right now. Let's see. What do I look out for when I get a PhD application? Well, I guess the first thing I look for is this student interested in research, and do they understand what that means? You know, I don't want, the fact that you have a lot of hands-on experience with pandas or something, or Excel, for instance, that by itself might tell me that you might be a good data scientist or a good machine learning engineer, but it doesn't tell me that you are interested in the sort of fundamental questions in the field, the research questions, the foundations. And so I'm looking for someone who's wants to study, for instance, well, let's understand why deep learning is failing in certain situations. What is it about the learned representations that is wrong? Right. So this is I will talk about that actually in just a little bit in my next presentation. Is what are the challenges for machine learning? And because those are the things that researchers want to work on, is what doesn't work today that needs to be repaired or fixed or overcome so that we can have a better technology for tomorrow. So let's see. I'm not sure, how am I doing for time? Fumini, what's the
yes, so this session ends. So this session is to end by 5.
Okay, which for me is 5 is 17 minus 9 is
so,
8. Okay, so we still have plenty of time, right?
Yeah, we have about 40 minutes.
Okay.
So just a quick one. So it's meant to end by 4:30. 4:30
Sorry?
because there's a session by 5 o'clock.
Okay, 4:30.
Yes, yes.
So we have
Because
about 10 minutes.
another
That's
session
good.
by 5
I think I need to, yeah, make some coffee
yes,
before the next session.
session. Yeah,
well, I had looked at some of the questions that I was sent in advance. Let me make sure that I covered all of those. People asked me who my mentors were. Well, mostly, I've learned a lot from so many people. I would say, of course, I did my PhD in Ed Feigenbaum's lab at Stanford University, and I learned a lot from him. Prior to that, some of you may have heard of a man named Donald Mickey, who was a professor at University of Edinburgh and various other places in the UK. He actually worked with Alan Turing at Bletchley Park during World War II on code breaking. And he was working in expert systems technology back in the 1970s and early 1980s. And he gave me lots of good advice. Yeah, I guess those are my main mentors. I mean, I'm a huge admirer of people like Michael Jordan at Berkeley, Rob Tibshirani and Trevor Hasty at Stanford in statistics. These are people who are very clear thinkers, and you know, I think they just do remarkable work. And one of the things that Michael Jordan did for many years, even after he became a professor, was he continued to take classwork in mathematics, so that he, because you just cannot know too much math. And this has been very helpful for him in basically importing ideas from mathematical physics, such as variational techniques, into the machine learning field. That was one of his big contributions. Let's see. Here was an interesting question, I guess. So, are there opportunities for a Master's of Science program in data science at Oregon State? So we have an online class, a degree program in data science that's offered jointly by statistics and computer science at Oregon State. Another question was, I am currently taking a course on quantum computing. Is there really light at the end of the tunnel career-wise? Well, we don't know for sure, but I believe from talking to the people that are working on quantum computers that although they're not stable enough yet, they can't maintain entanglement long enough, I think they continue to improve, and that within the next 10 years, we will definitely be doing some interesting quantum computations. And some of those may be in machine learning, actually, because of course, machine learning involves solving some optimization problems always. So I think it's a promising area. Of course, there's some risk, but what you learn there will be useful even if quantum computing as a hardware technology doesn't take off. People are finding that designing algorithms from a sort of quantum perspective often leads to new algorithm ideas. Those can then be de-randomized and used. So so that's an area to continue to explore. Okay, what advice do you have for people without a mathematical background who are trying to switch to data science? Well, I would say you either need to learn some mathematics, or another possibility is to focus more on the software engineering side of things, like machine learning operations, ML ops. As I think I may be repeating myself, but when I talk to people in industry, I see that there's this huge need for people who understand the process of continuous deployment and improvement of machine learning systems. I mean, machine learning in theory should allow companies to be more agile because you can easily retrain the systems. But in practice, there's always the risk that some contamination in your training data, because you're collecting new data all the time, that might cause the resulting system to behave poorly. So you need to be monitoring the performance of the system and be able to automatically roll back to the previous version if a new version isn't working well. So you have to have continuous tests, and you need to be detecting changes in distributions and all kinds of things. So that's so I think ML ops is a growth area. The tooling is still maturing, and I think it's going to be a great place to be going forward. Let's see. Let's see. How can I get a machine learning job? What steps should I take? Well, as I've said, I think a great thing is to work on an application from initial conception all the way to deployment, then document that on GitHub, and then use that as your calling card for applying for positions. But also, you should think about where you want to be in this sort of spectrum of data science jobs. Data analyst, who basically just uses existing tools, all the way to a researcher who doesn't use any existing tools, but is always building new stuff. Here was a person who asked, my career goal is to be an emerging leader in environmental data-driven organizations. My question is, what advice do you give to someone with no first degree in the subject matter? I think the key in cases like this, and it applies to all the fields we've been discussing, is you need to find a collaborator who has that expertise and then work together on a series of problems. Again, starting with very simple problems and moving on to more and more complex ones. Let's see. What was the blueprint for your success? I think early on in my career, I got a reputation as the person that knew the literature very well. I had the advantage that when I started, machine learning was just starting. And so there was a time when I had read every article that was about machine learning. Of course, this was before we discovered that statistics was an important field to know. And so very rapidly, I lost the ability to say that I'd read everything that was relevant. But I think the important thing is to read the literature and then organize it into a coherent mental framework. So you can't expect to read the whole literature, but if you dive into an area, you need to build a sort of knowledge base in your mind about what are the different problems people are working on, what are the different approaches they're taking, what's working, what isn't, why not, what are the open problems, what are the promising research directions. The other thing I think is to build a big academic social network. So when you go into a field, you're not just engaging with the ideas and the code, the math, you're joining what could be thought of as sort of a virtual community, right? I mean, if you took all of the people that are working in data science these days, you might have what, 50,000 maybe worldwide? Maybe that's an overestimate, but it's like a very small city. And you are now a citizen of that city. And so you should volunteer and serve the community, but you also just need to get to know a lot of people and build your academic social network. And so speaking of that, I will be happy to connect with all of you on LinkedIn. So you can send me connection requests, say you were in a DSN, and I'll accept you as a connection there. Let's see, how are we doing for time? I have 1 more minute. Let's see, what should be my last? Is it possible to combine data science alongside academics and be very productive? Well, I think a lot of people outside of computer science and statistics are now applying data science techniques in their research and development activities. So the answer is definitely yes. It becomes a tool for advancing whatever scholarship you are doing. This was particularly someone who was studying combinatorics at a Russian university. So I think, you know, it'd be interesting to look at problems that, practical problems that involve combinatorial optimization. So I'm familiar with some in logistics, but I'm sure there are many, many others particularly in graphs, social networks, other kind of network data. And then think about what are some of the techniques on the combinatoric side that might provide an opportunity to apply machine learning, either as a tool in combinatorics, but more if we have a combinatorial optimization problem, how do we represent the shared or reusable knowledge for solving many, many combinatorial optimization instances? I think about one of them, or one kind of line along this is, you know, that there's a lot of interest in solving satisfiability problems, so-called SAT problems. They're so the question is, you have a collection of Boolean logic statements, so over a set of binary variables. And the question is there a truth assignment to the binary variables that makes all the statements true? And so that they are all satisfied. And this is a core problem that if you can solve this, you can solve many other things. People have found that standard solvers for these problems, things like there's something called DPLL, which is a Davis-Putnam, and I can't remember the other two names, procedure, which is a systematic search procedure, that it exhibits a long-tailed behavior. That some problems it will solve very quickly, and others it could take you know, essentially exponential time to solve. And so people took advantage of this to say, well, if it hasn't solved the problem within a certain amount of time, stop it and let's reorder the axioms and restart it with a fresh start. And this also applies to randomized algorithms that often, if they have a heavy-tailed, long-tailed distribution to their running times, it's better to randomly restart them after a certain period of time. And so, and you can use machine learning to try to identify and automatically configure those algorithms. Okay, well, I guess our session is done. We have 54 seconds now.
Thank you so much, sir. Thank you for
I hope this was useful.
Enlightening time. I'm seeing so many appreciations in the chat window now. Thank you so much for your time. Thank you for coming again. Would have been lovely to have you down here physically, but we understand. Thank you so much.
Yes.
We really
I hope to return to Nigeria sometime in the future.
We hope to have you too. Thank you so much.
Okay, well, it's great to see you again and to meet all the rest of you.
Awesome.
Bye-bye.
Bye. So we look forward to the big picture session.